fine. Okay. So yes, we are going to discuss about this topic, that is the pressure in the gases. And when we talk about the pressure in the gases, actually, this topic deals with atmospheric pressure. This topic deals with the pressure in all type of gases. What happens in the gases actually? In gases, there are some particles. There are number of particles inside a gas, and they have very high velocities because gas particles move freely, and this large number of particles, they cause collisions with each other with walls of the container, and then you know due to these collisions, what happens? Their momentum is changed. This is really important thing, that when they collide with the walls, these air molecules hit the walls, and thereby they rebound from the walls, and a force is created, or a force is built. Here I will add one point, that the force is actually due to rate of change of momentum. If you people knew that what was the change in momentum topic, the resultant force was equals to change in momentum divided by time, isn't it?
Yes, sir.
Okay. So when the particles collide with each other and with the walls of the container, what happens? Their velocities are changed, they rebound, and their momentum is changed. And when their momentum will be changed, that momentum will cause a force, and that force is exerted on a unit area of the walls. That is why force per unit area is equal to pressure. And there are several particles colliding at once. That's why the pressure is actually the sum of all the forces over there. So that is why when I just consider this, that the particles have the particles in the atmosphere or particles in the air, they collide with each other and with the container, if they are in the container, otherwise no, then what will happen? They will exert a pressure, and this pressure at the sea level is actually 1.1 into 10 raised power 5 Pascal. It is not 105, it is 10 power 5. So I will just correct it. It is 1.013 into 10 power 5 Pascal. That means that it is 101300 Pascal actually. But in your uh, exams, mostly in your past papers, this is given 1.0 into 10 raised power 5 Pascal. So, Mariam, this is the pressure which is actually exerting on this, which is provided by the gases of the atmosphere at the sea level. Okay,
Got it, sir.
then we have the gas laws, or pressure in the gases. There is a laws of gases. So, in
Sir, but
laws of gas,
I'm sorry to interrupt, but
no issue.
how does how is the pressure exerted on sea level again?
Yeah, actually, when the gas molecules collide with each other, because they are not in the container, na? So that container situation will be then gone at sea level or in open air. This is for closed container, right? So what I have written, that they collide with each other and with the walls of the container. This is for the closed container. But in open air, when they collide with each other, they cause change in momentum. And when they cause change in momentum, actually, they cause pressure.
Mm, got it, sir.
Got it? Okay, so here is that last uh, stroke for the pressure of the gases. That when we have the laws of gases, the law which deals with pressure and volume, that is called your Boyle's law, that state that a volume of a fixed mass of a gas is very important. You are not going to change any number of molecules so that it can exert more pressure or something like that. At a constant temperature is inversely proportional to pressure. So here there are 2 points which what you have to manage, or you have to recall, that volume is direct inversely proportional to pressure. Volume is inversely proportional to pressure. Right? It is very simple. If it is asked to you, what is the relation of volume and pressure of the gas? So pressure and volume are inversely proportional.
Okay, okay.
Okay, now I'm going to tell you one trick that if pressure is inversely proportional to volume, then I can say that pressure is equals to any constant divided by volume, and then this P into V will be equals to a constant. K is actually the constant here, right? Is it clear to you?
Sir, could you repeat, please?
Yes. For example, did you study the proportionalities in your maths?
Yes, sir.
When we say y is directly proportional to x, how do you write it? You write it y is equal to
Yeah,
kx or not?
yeah. I get it.
And for that one, you say that y divided by x is always constant. Then, yani, if this happens, then y is directly proportional to x. I mean, if you divide two numbers and for every corresponding value, they are giving you the constant ratio, then they are directly proportional, isn't it?
Yes, sir.
In the same way, if you multiply two numbers and they give you a constant answer for all corresponding values, it means they are inversely proportional, isn't it? If this
Yeah.
is happening, so pressure is inversely proportional to volume. Is it clear to both of you, Khadija and Mariam? Yes,
Yes,
Khadija and Mariam.
yes, sir.
So I can say that in any case, in any case, let's say I have a gas container. Suppose I have not actually drawn the diagram here, but let me draw it for you. If this is a container, and in that container there is a volume of the gas like this. Here is the volume of the gas. This is the piston for which you have you just place it just like a syringe, nothing else, right? There is a piston, and that piston is actually movable in this cylinder. Then what do you think? What will happen? This gas is having a specific volume, na,
Yes, sir.
isn't it? These are the molecules what I have contained here. So it means at this situation, is its pressure is P. Here I'm going to apply some force on a specific area, and force divided by area makes a pressure. So I can say that at pressure 1, volume is V1. But when you are going to increase this all setup or change this all setup, then just tell me that when we are going to have the second situation, let's say now you have just increased you have just um, increased the pressure. So when you are going to increase the pressure, what about the volume? Will that gas be compressed or not?
Yes, sir. It will be.
Let's Yes, let's say this is the new position of the piston. Okay, so when it is the new position of the piston, what do you think? What will happen at this new position?
The volume will be less and the pressure will be more.
Yes, volume is less because that object or that all gas has been compressed here. So all the molecules which are above, they have been changed. So now new volume is V2, new pressure is P2. The condition is that P2 is greater than P1. So your V2 is less than V1, isn't it?
Yes.
So that is why when you say that P1 V1 is equals to P2 V2, this is an equation which is used to solve the questions or which is used to calculate the pressure at any situation. For example, if I say that volume of the gas is 200 cubic centimeter here, when the pressure was, let's say, 1.05 into 10 raised power 5 Pascal. And now, what will be the volume of the gas if you have new pressure P2, that is equals to 1.08 into 10 raised power 5 Pascal, right? So what equation you will use? You will use that equation, P1 V1 equals P2 V2. You will be able to manage, for example, P1 V1 equals P2 V2, and I want to calculate V2. Here V2 will be equals to what? P1 V1 divided by V, divided by P1. Sorry, P2. Sorry. P2. So just put the values. Your P1 is 1.05 into 10 raised power 5 Pascal. Your volume is 200. No need to convert because mm, volume will be coming in cubic centimeter, and new pressure is 1.08 into 10 raised power 5. So when you will just solve that, 10 power 5 will be cancelled by 10 power 5. Do you people have calculator?
Yes, sir.
Yes, so please calculate 1.05 into 200 divided by 1.08. Yes.
Just a second, sir. 1.08
What is the number? Khadija, do you have calculator?
5. Sure, it's 194.44.
One.
194.44.
Yes, cubic centimeter. So did you see that volume has been reduced?
Yes, sir. Sure, but I have a doubt.
Yes.
Um, how is P1 V1 equal to P2 V2? Like, can't there be
Actually,
any other
when you
relation?
multiply the pressure and volume for this state, P1 V1, that gives you a constant number. And when you have multiplied the pressure and volume of this state, that gives you again a constant. So if I write two equations, P1 V1 is equals to constant, and P2 V2 is equals to constant. So right hand side of both equations is constant, isn't it? Okay, are you getting? So P1
Yes,
V1
sir.
will be equals to P2 V2. I mean, left hand side is same, so right hand side will be same.
So basically, the constant is equals to the constant.
Yes, so there is one or more method, na? So you can divide them. Constant will be cancelled out.
Oh, yeah, got it.
Got it?
Yeah.
Anything unclear, Khadija and Mariam both?
No, sir.
Okay, so in case of graph, uh, you will have this. No, just a second. I'm going to put one more page here to show you the graph calculations, and then I will move to the practice of the questions. Okay. In past paper questions, there are some topics, there are some questions which are excluded now from the syllabus. So I will mention those for you, and then we will move forward. So here is the graph of pressure and volume, right? Pressure and volume graph is that if we have volume or pressure to be plotted, then they can be plotted in this way. if this is pressure or the volume R, vice versa, volume and pressure. I'm just going to label these all. Don't worry, this is your pressure and this is your volume, and here this is your volume and this is your pressure. So for both of them, the graph will be, let's say this is your P, so this will be your P by 2, pressure is half, and this is your P by 4. Is it? Are you getting it? So if this is your V, so this is your V by 2, and this is your V by 4. So the beauty of this graph is that it does not touch the axis. None of the graph touch the axis. So it does not touch axis, right? Because at zero volume, pressure will be infinite, and at zero pressure, volume will be infinite. Is it? When V will be equal to 0, pressure will be infinity. And when pressure will be 0, volume will be infinite. Right? Are you getting this point? So, if usually it is given to you that if pressure is P here, then at uh, double the volume, pressure will be half. And when volume will be, when the volume will be increased more, pressure will be half again. So you will have this type of curve. Okay, usually it is called isothermal, right? What do we call it? Isothermal. Is it clear? There is a curve. So generally I'm drawing it without values. Without values, this is without any value. Okay, so these are the graphs. But this is not a straight line, this is a curve. Are you people in my class?
Yes, sir.
मैं क्लास लेट शुरू की थी सीधा तकरीबन 8:45 तक के सेम में. Okay, is it clear to you?
Yes, sir.
Okay, then there is another law that is called Charles law, right? That is called your Charles law. Actually, this law deals with volume and temperature, right? It deals with volume and temperature, and it says that volume is directly proportional to temperature, but not in degree centigrade. This is very, very important statement, right? Celsius are in degree centigrade, right? So don't confusion here. I have just
Sir,
written
just give me a second. I will be
deliberately,
back.
okay, that volume and temperature are directly proportional, but not in centigrade scale. Temperature should be temperature must be in Kelvin, SI unit. Temperature must be in Kelvin. This is really, really important point, right? So it means that actually it is simple thing to understand that at 0 degree centigrade. Khadija, are you in the class?
Yes, sir.
Okay. At 0 degree centigrade, volume is never zero, but at 0 Kelvin, volume is considered as zero. So that 0 Kelvin is called as absolute zero, right? What do we call it? It is your absolute zero. Absolute zero is after also named as absolute temperature, right? What else we call it? It is a absolute temperature. So this is an important game here, that when you will draw the volume and temperature graph, you will have some uh, difference in Kelvin and centigrade, right? And that is, let's say I'm going to draw a graph here. It is your temperature, and it is your temperature, sorry, it is your volume, and it is your temperature in degree centigrade, right? Then the graph will never start from zero. This graph, it never starts from zero, right? Remember this thing, that it never starts from zero, right? It starts from any non-zero value of volume. So we can simply say that this is actually the graph. This will be the graph. If you are given this graph, remember this thing, it will never be zero. And this is actually the volume at 0 degree centigrade, right? What is that? This is the volume at 0 degree centigrade. Right? Are you getting it? It is 0 degree centigrade. So if a graph is not passing through origin, can you say that this is directly proportional? Hmm?
We
Khadija?
can't, that would be inversely.
No, 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 no. It is not inversely. We just say that as temperature increases, volume increases for in this situation. So what do we say? That as temperature increases, as temperature increases, volume increases, right? But not directly proportional. Remember this thing. But not directly proportional. Okay, is it clear to you? Is Mariam back?
So can you explain again?
Yes. For example, for probability constant, I mentioned all the conditions. What is directly proportional? That when you divide y with x, answer should be constant. So let's say I'm going to divide this number with this value. I will get a I will get a number. And for this value, and I will divide this, I will get a constant number. But when I will divide this zero with this non-zero value, will I get a constant? Will I get the same number?
क्या मतलब?
देखो, मतलब ये कि let's say I have a graph. ठीक है, ये ग्राफ है आपका. So this is directly proportional graph. ठीक है ना? Do you believe that it is directly proportional का graph है? Actually, which property of the graph tells us कि ये directly proportional का graph है? Let me put some values. Here is no grid available for me. That's why I will just make it simple. Let's say it is 0, it is 10, it is 20, it is 30, it is 40, isn't it? This is your x. And for y, it is 10 or 100, it is, let's say, 200, it is 300, Okay, and it is your 400. This is your y. Okay, so just a simple calculation. For example, if I want to calculate the value at 100, sorry, at 10, what value I get? This one. अज्यूम कर लेते हैं कि ये 100 है, ठीक है, थोड़ा ऊपर लेके जाते हैं 100 को, जस्ट टू मेक simplification. Although it would be 120, let's say, let's make it 100, right? तो अब मुझे ये बताइए कि what will be value here for proportionally constant? Y is 100 divided by 10, so your answer will be 10. Is it? Are you getting my points?
Yes,
Khadija, are
sir.
you there?
Yes, sir.
अब मुझे ये बताओ कि if I'm here and I'm getting this number, oh, just a second, ठीक है? So at this point, what will be the value? I mean, what will happen if I divide them both? For this value, at this point, it will be 200 divided by 20. Again, you are getting 10,
Yes.
isn't it? In the same way, 30 by 300 हो जाएगा ना? Should I draw it again? Calculation की जरूरत तो नहीं है. Is it fine now? Did you get it?
Yes, sir.
अब आते हैं इसमें. There is a graph, and that graph is this much, this way. Okay, are you getting it? Green one. I will perform all calculations with green.
Yes, sir.
For this graph, for this 10, what is the value? Almost 150, है ना? So here you are getting 150 divided by 10. It is 1.5, isn't it? Are you getting?
Yes, sir.
What about this points? 100 divided by 0,
Yes.
infinite. What about this points? 30 पे 300 पे जाना चाहिए था ना? So
250.
it is almost 220 कर लेते हैं. So at this point, 220 या 230 divided by 30. So what are you getting? What is your number? इसको 240 कर लेते हैं, चलो easy calculation हो जाएगी. So isn't it giving you 8?
8. Yes, sir.
है ना? So check करो for all greens. Did you get a constant number for calculation of for division of y by x? यानी y1 divided by x1 is infinity. Y2 divided by x2, which is here, it is 1.5. Y3 divided by x3, you are getting 8. So is it constant? So I can say y divided by x is not equal to a constant number. Is it clear to you?
Yes, sir.
तो इसका मतलब ये हुआ कि green line is not directly proportional line, है ना?
Yes, sir.
Does not show directly proportional. But what about red one? Red के लिए आप क्या लिखोगे? But the red one, for red one, y1 divided by x1, अगर मैं 0 by 0 करूं तो it means this is 0 a constant number, ठीक है, infinity तो नहीं है. y2 divided by x2, that is this one, sorry, this one, so that was 10. Similarly, y3 divided by x3, 10, and so on. चलते जाएं तो आपके पास constantly 10 आ रहा है. Are you getting my point?
Yes, sir.
So that is why when they are following the relation of proportionality constant, that graph is your constant number. That graph is your that graph is directly proportional graph. अब देखो प्रॉब्लम सारा यहाँ पे आ रहा था. What I told you, if this is not getting zero, तो इसका मतलब टेम्परेचर के साथ वॉल्यूम इंक्रीज तो हो रहा है, बट इट इज नॉट डायरेक्टली प्रोपोर्शनल. सो एक काम और करते हैं, just drawing this graph for you and giving you the final conclusion. देखो, this is the graph where this is your 0 degree centigrade, right? But that is in, okay, centigrade में कर लेते हैं इसको. That is a centigrade. So when it was in centigrades, just check it out that when I have drawn that one, this was basically starting from here. Is it? ऐसे ही होगा ना? Are you getting my point? तो अब मैं इसको अगर यहाँ से I join it back over here, what do you think? It is minus some number, na? है ना? It is 0. Let's say it is 20. Suppose it is 40. Suppose it is 60. Suppose it is 80 and so on, right? Khadija, Mariam, is Mariam not back?
Sir, I am back.
Okay, okay, okay. तो मैं समझा कहीं भूल ही गई हो क्लास को. So can I write this one? This number is your 273 degrees centigrade. Remember one thing, right? So this is your volume and this is your temperature curve. So remember one thing, that this is what that temperature minus 273 degrees centigrade is absolute temperature, right?
Sir, what is the meaning of
Absolute,
absolute temperature?
that is, the gas molecules will be absolutely frozen. They will have no kinetic energy. At this temperature,
This is minus 273 degrees Celsius, the absolute zero temperature.
yes, yes, exactly. So at this temperature, no, yani gas molecules have no kinetic energy. So I'm just writing one sentence, that molecules have no kinetic energy. Okay, no kinetic energy. So it is called 0 Kelvin. Okay, 0 Kelvin. So simply speaking, that 0 Kelvin is equals to C minus 273 degree. So from here, you can simply make a relation. You can simply make a relation of temperature in Kelvin and centigrade. Temperature in Kelvin and centigrade. This is in your syllabus, that temperature in Kelvin is equals to C plus 273 degrees. C plus 273. For example, you have to recall it. No need to derive it. For example, as I told you, that when Kelvin is 0, when this number is 0, so what will be degree centigrade? 273 is here, so it will be shifted on the other side. So centigrade will become minus 273 degrees centigrade, right? So simply speaking, or just giving you a final shot, that is, just consider that if your body temperature is 37 degrees centigrade, right? So what will be it in Kelvin? It will be 37 plus 273. So it would be 310 Kelvin. What will be that number? Sorry for inconvenience. It will be 310 Kelvin. You have to recall it, please. It is to recall. Memorize it. not to derive it. ठीक है जी, ये बात क्लियर है. So this was actually the last part of your pressure in gases and relation of that with temperature. This ये जो मैंने part करवाया है ना, this one, it is somehow used in your thermal physics also. But as it was mentioned in the syllabus at this position, that's why I just told you this right here. Okay, is it clear to you? Hello.
Yes, sir. It is clear.
Okay. Okay. So now, if you have